Hey there folks, Mr. G here with another educational video. This video is the start of our crash course on Chapter 6, the chapter that we skipped, all about rational expressions. Because we're trying to cover an entire unit in a series of videos, the videos will probably show fewer examples than I would typically, but it gets across the most important points and shows you the most important examples, though it might not have quite as many easy examples as you're used to. Before we dive in, I think it's important to dissect the word that we have at the start here. This is a word that sort of defines our whole chapter. The word rational has the word ratio in it, and a ratio means the same thing as a fraction. This unit is all about fractions, and in particular fractions that have polynomials. Fortunately for us, all the same rules still apply. Some examples of rational expressions include the following. We can just have regular fractions like 5/8. We can have fractions that include variables like x. We can have other variables like z, and they can get as complicated as we like as long as they have this line in the middle. As long as there is this dividing line in the middle giving us a fraction, it is going to be a rational expression. Now when we talk about rational expressions, it's important to also think about restrictions. And the restriction for any rational expression is that the denominator can't be 0. Remember, when we have a fraction, it's the same as dividing, and we can't divide by 0. Let's go through some examples where we try and find the restrictions. For our first example here, 10x/7, there's no way we can make our denominator 0, so there's no restriction. If the x is on the bottom now, there is going to be a restriction because we can make this bottom 0 if x is 0. So our restriction is that x cannot be equal to 0. This avoids dividing by 0. Now we have x minus 2 over x minus 3. Our restriction is only if the bottom is 0. So we don't care if the top is 0. We're allowed to have 0 divided by a number. So for example, 0 divided by 3, that's fine, that's just 0. But if we have 3 divided by 0, this is undefined. So back to this example here, we don't care about when x is 2, but when x is 3, that'll make our bottom 0. That's our restriction. X can't be equal to 3. When we have a more complicated example like this, what's most important to do is to factor the bottom to try and see all the different ways that our bottom can be 0. This is a perfect square, so we can factor it as x minus 3 times x plus 3. If either of these two parts is 0, since they're being multiplied together, the whole thing will be 0. So our restriction in this case is that x can't be -3 or +3. For our last example here, in this case, again, we would want to try and factor our bottom, but notice we have a sum of squares here, and we can't factor it. Since we can't factor the bottom, there's no values of x that can make this bottom 0, so there's no restriction. Next, we want to talk about simplifying rational expressions. Just like we would simplify fractions, it's going to have the exact same rules. So if we started with an example like 12/18, what we can do is factor the top and the bottom into the prime factors. We can do this using a factor tree, and then putting all these factors together, we have now factored out 12 and 18. Once we have it all factored out like this, we can just start canceling the same thing on the top and the bottom. So we can cancel out those two 2's and these two 3's, which leaves us with our final answer of 2/3. The important thing here is that we could only cancel them out once we had everything multiplied out on the top and the bottom. This doesn't work the same if it's addition. For example, if I break these two top and bottom parts using addition, I could get it as 10 plus 2 on the top, 10 plus 8 on the bottom. And you'll see this very commonly when doing rational expressions, where if this was an x, people think, oh, I can just cancel out these x's. And that would leave me with an answer of 2/8. But that's definitely not true. The key part is that all of these things, all of these factors are being multiplied together, and that's what allows us to cancel on the top and the bottom. So same with fractions, just like our rational expressions, we factor the top and the bottom, like we saw here, and then we cancel out our factors to get our final answer. So for our examples here, we're going to state our restrictions, then simplify. Remember that when we state our restrictions, in order to do that, we need to factor the bottom here. And we might as well factor the top while we're at it. Starting with the top, I can take out a common factor of 4. On the bottom, we've got a difference of squares, which means I can factor it using our special case. Once we factor out all of this, remember we care about where the bottom is 0. So our restriction would be that x can't be -2 or +2, because that'll make the bottom of our fraction 0. Keep in mind, you have to state these restrictions before you simplify. Once we have everything being multiplied, just keep in mind all of these things are being multiplied together on the top and the bottom, we can see that we have a factor on the top and on the bottom we can cancel out. and we get our answer here with our restrictions. Now this example definitely looks a lot scarier, but we're going to do the exact same thing we did, which is to start by factoring. I have a common factor of x on the top and the bottom here. Now you might be tempted to cancel out the x on the top and bottom, but let's finish factoring first because we still need to do our restrictions before we start canceling out. If we do our restrictions before we cancel out, we're going to miss some of our restrictions because this x would disappear from the bottom. On the bottom here we have a difference of squares, which we can do quite easily. Be careful that because the 9 comes first, the 3 would come first in each of these. Don't flip them around. For the top here, we have a hard trinomial to factor. Hopefully you remember how to do it. I'll go through the steps here. We're looking for two numbers that add up to give -1, this middle, and multiply to give our first number times our second number. So we want two numbers that multiply to give us -30. That means the numbers we're looking for here are -6 and +5. We then split the middle using this. We factor the first two and factor the second two. Now we have a common factor at the start and the end. We can factor that out to get our final factored form here. At this point we factored everything, so we can state our restrictions. X can't be 0, 3, or -3, because that would make our denominator 0. Now you might be looking at this and thinking, well, I've got a common factor I can cancel of x and x, and there's nothing else. But be careful, because these two right here are very similar, and we can actually cancel them out if we're being clever about it. If I have 3 minus x, this is the same if I factor out a negative sign as -x minus 3. If I put it in this form, I can cancel out the top and the bottom. Once we've rewritten it like this, now we can see clearly we can cancel these two out, and I'll pull the minus sign out front to give us our final answer right here. If you're worried about catching these sorts of errors and maybe missing this in a question that you're doing, my suggestion is to instead change it at the start here. Anytime you notice that you have a lower power in front of a higher power here, just reorder it so that our highest power is positive. If you notice that your highest power on the top or bottom is not positive, you can rearrange it so that it is positive. So I could have at the start changed this to -x cubed minus 9x. And that would have fixed this problem before it even started. When we're doing this simplification of fractions, really what we're doing is dividing a factor on the top by a factor on the bottom. And this is very similar to when we actually multiply and divide whole rational expressions. So when we multiply or divide entire fractions, say for example 6/7 times 14/9, what we would do is factor each of our individual fractions, if we can, like this. And now what we can do is cross-reduce. So we've got a 7 down here, we can cancel that 7 up here. A 3 down here cancels with that 3. But be careful, if we have two 2's on top, those don't cancel out. Those will actually multiply together and give us an answer of 4/3. Very similar to simplifying, we're going to start by factoring the top and bottom. We'll cross-reduce, canceling out factors for each part, and then just multiply the remainder on the top and the bottom to get our final answer. If we want to simplify this expression right here, again we start off by factoring, but wait, before we start factoring, notice here we've got a similar problem to what happened in our previous example, where we had a larger power that was negative. Here our largest power is also negative. So my suggestion would be to quickly flip this so that it's -3x minus 15. That'll save us some headache in the future. In our first fraction, the top and bottom are both difference of squares, so our first fraction can be factored like this. In our second fraction, we can't factor the top, so we'll just leave it alone as x minus 2. On the bottom here, we can pull out a factor of 3, and now we have both of our parts factored. From here, we can start canceling out the x minus 2's, the x minus 5's, and finally multiply everything. The only thing we have left on the top is x plus 5, and then on the bottom we have x minus 2 times -3, and on the bottom we have -3 times x plus 2, and if you'd like you can move this negative sign, instead of being on the bottom, you can move it right next to the fraction. That's typically where it's put. So that's our final answer. What about something like this? Now this looks very scary. First thing to notice, we're not multiplying anymore, now we're dividing. When we're dividing fractions, I want to give you a quick reminder on how we would do this with regular fractions. If we had two fractions being divided like this is the same as multiplying with the second fraction reversed. And as I've said many times already, the rules for these fractions are the same as these fractions. So we can just flip the second fraction and change this to a multiplication. While it does look really scary with all the x's and y's, we're still going to follow the exact same procedure and start by factoring everything. The top here, we have a common factor of x. On the bottom here, even though this looks really complicated, if we forget about our y's here, this looks like a simple trinomial. And because we have y and y squared, it's going to be the same factors as a simple trinomial, but instead of just being a number, it'll be a number times y. So if we think about x as being our variable here, what we want to do is find two numbers that multiply to give us our last part, negative 4y squared, and add to give the middle part, not including x, of negative 3y. What we're looking for here is negative 4y and 1y, which would multiply to give negative 4y squared, and when we add these two together, we would get negative 3y, and that would allow us to factor our bottom here. Similarly for our other fraction here, again, this looks really complicated, but it's just a simple trinomial. So two numbers that add to give negative 5y and multiply to give 4y squared. So we're looking for negative y and negative 4y as our factors. For this last part here, notice now we have y squared at the start and x squared is at the end. This is again very similar to this example where we have a negative x at the very end. So what we want to do is change this so that it's negative of all of this polynomial here. This has the added benefit of turning what looks like a hard trinomial into an easy trinomial. There's a 1 at the start here. So we want two numbers that multiply to give us negative 3y squared, add to give us negative 2y. So negative 3y and y are what we're looking for. And there's our expression all factored. That was definitely not easy, but from here, it's not too bad. Now we're looking to cross reduce. We've got an x minus 4y here and here, an x minus 3y here and here. Be careful, we have an x plus y on the bottom on both sides here, but those aren't going to cancel out. Now we just multiply whatever's left over. We've got x times x minus y on top, and x plus y squared on the bottom. Don't forget that minus sign. And there's our final answer. That's the end of our first video. In the next video, we're going to be going over how to add and subtract, as well as do complex fractions with rational expressions. See you then.